Dave and I are the new owners of Skidmore Wilhelm as of 2006. We are kind of a motley crew. We started together in 5th grade. Dave and I were the new kids to the school district in Orange, Ohio, and we were the dorks who sat at the table who didn't know anyone else because we were new to the school district. Became instant friends. We've known each other forever. Dave is an engineer, so he's the brains behind the organization. I'm a sales and marketing and accounting guy, so I'm the mouth and the nerd behind the group. And I am a computer guy, but for some reason this doesn't seem to want to work for me this morning or this afternoon. Did it go? Did I screw it up?
Is it supposed to be showing up on your little screen there?
Well, it should be showing up there.
Yeah, it's showing what you're showing.
Something's showing. I restarted. Let me tell you a little bit about Skidmore. Skidmore started 60 years ago. We actually bought the company from John Wilhelm, who was the son of the founder, Jack Wilhelm. There we go. We're getting closer. It started as a machine shop way back when in the 30s and 40s, and as they grew, someone came to them. Actually, it was someone from Bethlehem Steel. They were putting up a local high school. I believe it was in Cleveland, Shaw High School, and they needed a way to test the tension in a bolt. They knew that torque was not the answer they were looking for, so they approached Skidmore Wilhelm. There we go. And Skidmore, who was the engineer, designed in about 3 weeks a bolt tension calibrator, and they were off to the races. And now it's become the standard in the industry for bolt tension calibration. We've grown into other products as customers have basically requested them. But as many of you know, there was no marketing presence ever for Skidmore Wilhelm. There wasn't much engineering other than Mr. Wilhelm and whoever the engineer of the time was then. And so they've never had a real direction to the company, but they did great. You know, there was no, I don't fault them for doing very well at what they did. What Dave and I are bringing to the table is engineering expertise. We own another couple of businesses as well. Our expertise is turnaround management and getting companies moving forward and utilizing new technologies to better manufacture and then to get into sales and marketing, which is my background. So that was my filler while we waited till the AV comes together. So let's talk a little bit about what Skidmore Wilhelm does. I'm going to go through a quick overview of tension versus torque, which is the whole reason that Skidmore exists, to determine, a lot of people use tension, and they really shouldn't be. And we'll talk a little bit about, what?
So you said tension and they should be. It's the
I'm sorry, torque, and they shouldn't be. They should be talking about tension.
That was a test.
Yeah, if anyone's listening. We'll go through a quick overview of the tools that we have. We have a number of different tools of different sizes for different projects. We'll go through those. Then we'll get into trends that we see in fasteners from our standpoint, from a measuring of tension in the bolt standpoint. Then we'll go into trends in structures. I'm sure most of you all know that probably better than I do, but we're seeing a lot of different applications for our products, and those are things that you might have to look into in the future. What kind of wrenches are becoming more and more popular? I don't know if anyone's using wrenches with torque reaction arms now, but that's something that we've had to develop a product to address that situation because the feet were breaking off of our tools. Then we're going to talk about some custom applications that we've done that may spark some interest in something else that you're doing. It's not really related to construction, but if you got any interest or you're doing other things, we certainly can talk about that. So what's the difference between tension and torque? Basically, the easiest way to describe it is you use torque on a bolt to create tension in the joint, and that's what keeps the building from falling down. That's the easiest way I can put it. If someone has a better explanation from an engineering standpoint, please feel free to speak up. But that's as a layman, that's what I know. Got anything to add
Pretty
to that?
accurate.
Okay, so what? So we know the difference between torque and tension. What difference does that make to me in the field? Well, for years and years, people were using a torque number, and in fact, we still get frustrated because the windmills they're putting up in Europe have torque specs right on the bolt, which we know is wrong. And they're still using those. So we're trying to educate people into the fact that tension is what you really want to be looking at, because tension is what keeps the building from falling. Torque is a number that you put on a bolt to get a required tension. A rusty bolt and the same torque is going to give you an different answer than a galvanized bolt with the same torque number. Well, guess what? You're not getting the same clamp load. That's what's the important thing that keeps the building from falling. So we're using tools so that we can tell you, and it's a very simple tool, we'll go through it in a minute, to tell you what the tension in your joint is. We don't care how you got to that tension. We don't care what tool you used. We don't care what the bolt looks like. We're strictly telling you what the pressure is in pounds of force in that joint at that time. Any questions? Feel free to speak up if you think I'm lying or if you think I'm mistaken. The number one seller that we use is that we have is our model MS, which we have right here. Basically, it's for 3/4 to 1 inch bolts. We can actually do up to 1.25 inches. Goes up to 94 kips. As some of you well know, that's 1.25 inches. If it's an A490 bolt, we can't do it in an MS because you need 107 kips or 103 kips, depending on which test you're doing. That's the model that's our biggest seller, especially in construction market. Today we're introducing, the first time anyone's ever seen it, is our new model MZ, which isn't in production yet. But as you can see, the fact that my partner can hold it over his head, it's much different than the MS that you're used to lugging around. The reason behind that is it's 100% aluminum. And we've obviously, we're doing this for you guys because you got to lift these things up and bolt them to the building. 2 years ago, 3 years ago, when we bought the company, we said, well, why aren't they all aluminum? And they said, well, people don't need aluminum. We said, I bet they need aluminum. So we've been developing it for 3 years. We finally have our first prototype. This summer, I think we'll be delivering them. We want to put it through some extensive testing because we don't want to put anything out there to, one, damage the Skidmore name and to cause any frustration out there. So we're being extra careful and making sure that we've got a product that's really going to work day one and we won't have any problems with it. Another couple things about that unit is it will do 130,000 pounds. So you can do your 1.25 inch A490s. You can probably do something a little bigger in an A325. That's one thing that customers have really asked us, because our old Model M used to go to 110,000 pounds, and we kind of took that away when the MS came out. It will also do all the short bolts that the MS will do. And once we get that out in the field and tested and make sure the Model H, which is the next item down, it's actually an HS, is an aluminum body with a steel piston, which we will go to all aluminum eventually once we get a working model that'll work. It's probably a year away once we get all the bugs, the kinks worked out of this one. The Model K is a large unit, which we didn't bring because the thing weighs 180 pounds. It's for larger bolts. We're seeing a lot more of those in the wind market. It's an exciting field for us because it's a big unit. We're getting to test a lot of bigger bolts. We've got a unit that we sent to Sweetwater, Texas for Vestas. Everyone's heard of Vestas, I'm sure. 64 millimeter bolt. That one will go up to 450,000 pounds. I think they had to go through to 350 on their, whatever their
At
test
least.
was. We also, in the non-construction market, we have models S, J, and P. Those are primarily used by fastener manufacturers or people testing tools. If you're interested in that type of thing, please give us a call. It's not really, it's for smaller bolts. We go down to number 6 bolts that we can test and give you tension results on. For those of you not familiar with Skidmores, you buy the unit, and then we need to buy a plate and bushing for every size bolt you're testing. Excuse me. Basically, we use this to keep the bolt from spinning in the unit so we can get a steady reading and an accurate reading on the tension in the bolt. So my beautiful assistant here will remove the one that he installed on there and show you.
This is what we call a bushing.
That's a bushing. And the plate is mounted here. And yes, we are working on a better way to mount plates so they can snap in. We don't have it today because it also has to be robust and live up to the Skidmore name. But look for that in the next year or so. We'll have an easy way to attach the plate without having to drive 4 screws in there. That's about it.
We'll show how it works.
Does everyone know how it works, or do you want to see a demo of plate and bushing being installed? We'll hold it up.
Oh, yeah.
There we go.
That's why we want a lighter one.
You want more bolts, not less bolts?
These?
Yeah.
Upgrade them to what?
Oh, you can use any kind of bolt you want. We buy those from McMaster Carr or Fastenal. It doesn't change anything. All it really does is hold the plate on here. It doesn't really serve any function to avoid any kind of thing other than keep this on here.
You get the retainer?
No,
Where'd it go?
did it go flying? Now the other thing we've done, and I don't know if anyone's noticed, I can hold this up, I don't know if you'll be able to see it. We're moving away from the dowel pins to hold the bushing in place because we get a lot of them sheared off, and you can imagine what we get back from the field to fix. This, we now have more, we've bought a lot of machine tools in our plant. And the first thing we worked on the first year we had the company was better manufacturing. Well, we have some machines now where we can cost effectively mill sides in this and mill slots on the
Here's the
bushing
bushing.
as well.
What that would look like.
So that holds it in place rather than having 2 dowel pins hold it. We're actually holding right across both of these sides. It's a little something to get used to, but once you use it, it's a lot better. That is available on our HS Now, and it will be the model that's used in our MZ when it's become available. So anyway, you need the plates and bushings. What a lot of people don't understand, and we get this a lot in the field, is, well, I'm using tension control bolts, and they don't fit in the hex pocket that you got cut in here. Well, we also have tension control bushings.
right
You just need to
behind
give us a call. They're inexpensive. They're not designed to hold anything because obviously how do you hold a circle? But it will create friction. You'll be able to use tension control bolts, and you won't be damaging these, which we get a lot. We get a lot of these back from the field where you can see where the tension control bolt just bit off the side of this thing.
Plus, it doesn't work.
Plus, it doesn't always work. Bolt styles that can be used in, and I just talked about tension control, the button head bolts, heavy hex. We also do standard hex. You guys probably don't see that, but we sell that to automotive markets and other people who are just testing fasteners. We do A325, A490 bolts, obviously, and I talked about how the new MZ will do the 1¼ A490s. We work a lot with the DTI manufacturers, both Turnisher and Applied Bolting, if you're familiar with what DTIs do. And for example, with Turnisher, you need to get the feeler gauge in there. We do special bushings and plates for DTIs. Just give us a call. We work with those guys. We know what the size of most of their DTIs are, and we can get you the right size unit to use with your DTIs that you're using on the project. Calibration, that's an interesting thing. The AISC requires calibration yearly on the unit for your audit. We recommend it as well. Previous administration at Skidmore said, well, that's not up to us to determine when to get the thing calibrated. We're taking a little more aggressive stand. We think the thing should be calibrated every year. Because of that, we have invested a lot of money in our calibration lab. And I don't know if anyone has been frustrated in the past getting it recalibrated with us. It was 4 to 6 weeks at times. Well, now it's 48 hours turnaround on any calibration. Just let us know. We have an expedite fee of $50, and we'll do same-day turnaround on any calibration. Get it out to you that afternoon, if needed. And we get those. We do a couple of those a week. So, and we're FedExing these things all over the country. Yes, sir.
Some of this calibration is done by labs around the country, not necessarily you guys.
Correct.
Are they following the same NIST standard you guys are when they do this? The people paying for these calibrations, how do they know it's being done properly?
It depends on the lab. There are some labs that we work with and help them to develop their standards. We do not have any kind of lab accreditation. So there are a number of people who need that for their ISO 9000 or ISO whatever they're going for. A good example is Northrop Grumman. We actually are used on bolts that are used in the space shuttle. Well, they can't send it to us because we don't have the accreditation they need, and frankly, we can't afford, it'd be millions of dollars to get that accreditation. So they send it to someone that we work with, and we tell them how we do our calibrations. It's really a simple process. It's not simple to get the machine to do it. It was a homegrown machine that we prove with a proving ring, if you're familiar with that term from Morehouse. It's a simple process, but not simple to set up the lab to be able to do it. So we have worked with labs, but we have also seen some people who send it to just a lab down the street has a press, and we wouldn't recommend using them because we get wacky numbers back from them. I mean, their reports that we get from the customer are not accurate. And so we're trying to make ourselves better and less expensive than those guys so that it's not even an issue. But in some instances, we will, if you know of a lab, we'd be happy to work with them. We're in the process of setting someone up in Europe to be able to do this in Spain. And he's going to set up his own lab because it's not cost effective to send things over the Atlantic. But does that answer your question? I think it depends on who's doing it, and we hope that they're doing it correctly. Now, all of ours we're tested by someone who's connected to we're one step removed from NIST at any given moment, and we're tested yearly on our presses. So we're hoping that they do something similar. Go ahead.
Can you help up the fab and the rector and say what is on the piece of paper that's okay? Is there a specific NIST test number? What is it that they should look for? Simple answer.
Simple answer is we do 4 data points, and we would like the thing to be tested within 1% of each of those 4 data points. For example, on the MS, we do 20, 40, 60, and 80,000 pounds. And we're tested, we were able to prove that with our proving ring that our press is producing 20, 40, 60, and 80,000 pounds. And we will adjust the gauge on the unit to be within 1% of that. Now, there's always it's only as good as the resolution that you're able to read on the dial. So I don't think you could read a 100,000 pound gauge within 1% either way, but that's what we're testing to according to NIST. Definitely not on the low range, correct.
So there's no ASTM spec or other testing spec that fits your equipment right now?
Not so far as I know, no. I think they've just used our standard, which was 1%. Any other follow-up to that? Okay. The types of wrenches that are compatible with our units, basically anything you can find out there, we've figured out a way to adapt it to our unit. One of the ways that we've done that is by a lot of these wrenches are now coming with torque reaction arms. And we started seeing units coming back to us with the feet broken off because somebody's using something out in space to hold the reaction arm. We've brought this for an example, and I will hold this up, but not over my head. This is a torque reaction arm for an MS, which we don't see very often because most people aren't using reaction kits, reaction arms on an MS type bolt, 3/4 to 1 inch, but we see it a lot more on our Model HSs and our Ks. And basically that's just to Dave can explain this better than I can, but it's to react against the arm so you're not creating a side torque on the unit, which not only can be inaccurate, it could be damaging. Anything to add to that?
Yeah, what happens is the load ends up being transferred to the mounting, through these mounting flanges, and what happens is you can snap it right off the I-beam, which makes for an interesting day, I'm sure. By putting the torque reaction through the body, you're keeping that all in there, and it doesn't affect the loading points at all. And what it does for us too is what happens if you start getting a load that's starting to twist things, your gun gets out of whack, and you can actually put side loads and twists in it, which will cause inaccurate readings. And that can be amplified on a TC bolt and a DTI especially, because those things need to come down nice and smooth and flat on there. So this solution has worked out very well. Like you said, we've done it up on the Ks where we're using, I think they were big torque up wrenches, 11,000 foot-pounds on there, and works beautifully, no problems.
Yes, sir. Gene?
Yeah, one of the things you might want to talk about a little bit is your spacers.
Yes.
The reason for that is if you're using a wrench that's got a reaction arm on it, you want to keep it close so it's going to hit that reaction mount you've got on the tool.
Yep.
Because if you start to push it away, for example, say you filled in with spacers on the nut side, now you're going to be out beyond that, and then you're going to have to react against something else. And if you react against something else, now you're, say, 4 or 5 inches away from the plate, you're going to just twist that skid wheel right off the flange of the column.
Absolutely. And in fact, we've been working with a number of people and we've developed what we call a spacer bushing as well, which is actually the hex head. Picture this, 6 to 8 inches long. So you're actually spacing, instead of stacking washers on the front, you're spacing out the back, moving the nut closer to the skid more. So you're reacting against, and this is something that we developed in the last year and a half, and it's going like gangbusters right now.
Especially in the wind turbine.
And we're advertising it, but right now we can't get an onslaught of them yet because we can't produce them fast enough because we're getting all different sizes. So what we're going to be moving toward probably is some kind of standard sizes for the most used bolts. They'll be available. If any of you have that issue and would like to address it with us, give us a call. We're custom making them now, but eventually there'll be a standard that we do.
Yeah, that's real important, being able to have just one spacer like that. Because basically, if you use like just 5 inches of washers, for about every 10 thousandths of compression you lose 1 kip of tension.
Right.
It's going to be very inaccurate. So this is a great idea, and I've got to applaud you guys for what you've been doing as far as changing the skid more and accommodating us.
Right.
Really great. Thank you.
That's without you guys, we're not in business. So we'll do whatever it takes to make you happy. Any other questions about that? We have spacers that we use to go out the front end. We never used to sell these, and we didn't understand why, and it was because people were stacking washers, and like Gene said, that's not a great practice. So we have made a concerted effort to at least announce these to new customers when they call in, and our sales of these have gone through the roof. So obviously there was a need out there for them. If you're not familiar with these, we make these in every size diameter, in 1/4 inch, 1/2 inch, 1 inch, 2 inch, and 4 inch sizes. We sell them as a kit. It's $185, and you get the whole kit. We also have I don't know if anyone saw us at the booth, but we have a box to hold it in, another Pelican case, which I don't know if anyone's familiar with the Pelican cases that we came out with. Mr. Pelican is familiar with them. We have rolling cases now, which is another thing that Dave and I implemented as quickly. It took us a year to find one that was durable enough We still have some tweaks we'd like to make to it, put better wheels on it, for example. But we have one on the market, and we can help you if you're tired of carrying that thing around. Back to the wrenches. Any type of wrench you can think of, hand torque wrenches, impact guns, they're all compatible with the Skidmore. Did you have a question, or are you just relaxing your hands? Okay. So go ahead.
Yeah, one quick note on where you're talking about the spacers.
Uh-huh.
The ones that you're gonna put on the front, you use those with impact wrenches and TC wrenches. You've got a tool that has a reaction arm, you've gotta use the bushing.
Right, exactly. Anytime you have a reaction arm, unless you have for the Model HS, we don't use this type here. We actually build bushings, and those bushings can stick out as much as 6 inches, depending on which one you're using. And we typically customize it for the gun that the customer is using at the time. But yes, definitely, if you are using a torque reaction arm, we want the nut as close to the face as we can get it. Trends in fasteners that we're seeing. Now this is related to the tension measurement that we deal in. So this is, you may see more things than we see, but a number of issues have come up to us. The bolts are getting shorter and shorter in length.
And longer.
Shorter and longer. And longer is no problem as long as you got spacer bushings and other spacers. Shorter can be a problem because if you don't get the stick through, you got nothing to screw up against. So what we've been doing is we came out with the HS 2 years ago to handle the larger bolts. The MS was already out. The S obviously stands for shorter bolts, and we're constantly moving that direction. One of the problems that we come against is if you get deflection in the plate, if the plate's too thin, if that thing's coming at a different angle, you can get inaccurate readings. So we get a lot of calls, well, if I can buy a short bolt plate, why can't I just use that for everything I got? Well, the reason is because we're nervous about that deflection in the plate because we know the kinds of forces that are going against that plate, and we also don't want it bowing in because that can be a problem as well. You can imagine what we see in these plates that come back to us. So we're very careful. We want to make sure that accuracy is number one. We'll get to the short bolts if it becomes more of an issue. We'll engineer something else. But right now, I think we've got a good handle on the short bolts that we're seeing in the field.
Question, I noticed on the new plates and bushings that you have, they're stepped. Now, is there a reason for that? Is that to prevent this bowing or by stepping it instead of just going all the way in at the same diameter? Or?
Exactly. What our engineering has determined is they want to go as thick as possible, but at the same time you want as thin as possible where the bolt actually sits. So to get the best of both worlds, they've made those step bushings to try to maintain as much stiffness in the plate as possible. It's that simple.
Any other questions there? So we're seeing shorter length. We're also seeing a lot more interest in direct tension indicators, the DTIs. Both the squirter from Applied Bolting and the what we would consider a standard DTI from Turn-Assure. And you may have seen the Turn-A-Nut that they've introduced that has not yet been approved by the governing bodies, but we can presume that they'll get there eventually. I mentioned earlier that we're using larger counter bores to allow for the feeler gauges for those. Similarly, with Applied Bolting, the squirter, they have to be able to see the squirt, and it can't be bugged down in a counter bore somewhere. So we've worked with those guys. If you're using those, please let us know, and we'll get you the right equipment for your particular job. We'll make the counter bore slightly larger so you're not coming up with any problems there. There's also an issue which we don't quite understand why they've designed it this way, but it becomes an issue. There is a chamfer on the hole for the plate. And if you're doing the DTI on that chamfered hole, in certain instances, if the DTI can slide to one side or the other and is hitting that chamfer, that can actually cause a problem. And we've been getting inaccurate readings. And of course, the first thing they do is come back and say the Skidmore's all wrong because the DTI's only giving me 3 three, whatever the, what are the,
Bumps, yeah.
three
refusals.
refusals, right?
Bumps.
And a lot of times that's the issue. It's we can make it without the chamfer. We're doing the chamfer mainly so it's not a sharp edge and people aren't cutting their hands while they're installing these things. If that's an issue, please give us a call because we work with Turnisher and with Applied Bolting to directly go after those problems. Go ahead.
Just a quick note on the Turner nut and the squirter, neither one of these are approved by the authorities, so to speak. In other words, they don't have an ASTM designation or a Research Council approval. I don't know if they're working on it or not, but basically with the squirter DTI, you still have to treat it just like a F959. The squirt gives you some indication that you've got tension on the bolt, but it's not considered an indication.
You still have to prove it out in the Skidmore, which is obviously why we work very closely with them, and we like them at the moment. Because you still need to use a Skidmore. The other thing is tension control bolts. Obviously, you all see tension control bolts a lot in the field. We see them a lot more often, and we get a lot of questions about tension control bolts, as you probably do as well. If you're using the right equipment, coming at it, spacer bushings, and making sure you're coming in with a direct torque to the bolt, we find that you have a lot less problems. There's always an issue also about temperature, which I will address in my later section. The answer, we'll talk about that later, but we're seeing a lot more tension control bolts, and I just want you to know that we've seen them, we have equipment to handle them, and if you have any problems with them, give us a call, because we've worked through most of the problems with all the manufacturers of those.
Got another question in the back there.
I'm sorry? Gene?
Another comment.
Sure.
One of the things with tension control bolts you want to watch for is if the bolt turns in the Skidmore, so if the head's turning against the bushing, the tension reading that you get is going to be lower than it would be if the nut was doing the turning. So if you're getting low tensions when you install one, make sure you check that the bolt isn't rolling. And if it isn't rolling, then you've got a bad lot. But if it is rolling, take something like a carburetor cleaner, just put it under the head of the bolt and just clean that lubricant off, spray the bushing with it, and so that you have more friction there. You install another bolt from the same lot, and you'll find 99 times out of 100, the tension will go up, and you've got the tension you really need.
Great, that's good to know. I didn't know that one, did you?
I knew there was problems with the bolts turning, yeah.
Yeah. Field practice, great, thank you. Any other comments? I don't know if anyone's done row cap testing in this room, and we get a lot of calls for people who need to do row cap testing, and they haven't a clue what it is. And when we explain it to them, then they say, well, I don't have 4 men and a young boy to sit on the end of a 12-foot torque wrench to get an additional 2 revolutions on an 1 1/4" bolt. Well, just about most of the bolt manufacturers now have our row cap tester, which is a gear-driven system that will record not only degrees of rotation, but torque and tension as the thing ramps up and also as the thing ramps down. So you can get, it was specifically designed to do row cap testing and to do a lot of it, and the thing pays for itself in a very short time if you're doing a lot of row cap testing. If you have any questions about that, please feel free to give us a call or see us after the show. We'd be happy to talk to you about that.
How much does that one weigh?
That weighs a lot. This stand alone weighs 600 pounds or something like that. I'm not sure what that gearbox weighs, but it's a lot.
And that's a 4,000 foot-pound gearbox, and it weighs a couple hundred pounds.
Just
And the
the
next size gearbox up, we're looking at one to do 10,000. I think the gearbox weighs more than that whole thing combined. So,
Yeah, we're getting a lot of calls, well, not a lot, but we're getting a few of our customers are asking for bigger row cap testers. So it's becoming more important.
Well, with that being that big, it's not portable then for job site use, and what kind of electrical current does it take?
I believe it's 220.
we've run it both ways. Either, I think he's set up Yeah, I think he's run it in 223 phase and then also a single phase, I believe. I believe so.
To my knowledge, the only
he
one
can
on a
run it
job
120.
site anywhere is the Bay Bridge project in San Francisco. American Bridge, Fluor Daniel bought one of these, and it's, I believe, sitting in a trailer right at the job site, and they need to do row cap testing on lots of 1.6 million bolts. So that's the kind of project that it's working on. But as far as I know, all the other ones are in labs. And if you just need to do a few tests, a lot of our customers will do that for you. They'll charge you $185 a test or something like that.
Yeah, but DOTs require you to do it on site.
Right.
We have to do them every day.
Yeah. The next thing we're seeing a lot is anchor bolts, especially for windmill projects and other types of things. You may think, well, how does a Skidmore work with an anchor bolt? Well, there are a number of different ways we can do it. We've even seen people install anchor bolts with a tensioner, then put a Skidmore up on top of it and test the tension in it after it's already been installed in the cement. We also do a number of tests where we double nut one side, run spacer bushings, and we can test those as well. So if you're running into problems where you need to test the tension in an anchor bolt, please let us know. We've worked on a lot of them, so we've become pretty good at it. And I don't know if anyone knows John Beal is our head engineer in that kind of stuff, and he's dynamite. Trends in structures that we're seeing, obviously windmills, and hopefully you all are seeing windmills a lot because it's a high growth area. Like I said, we didn't bring the Model K here, but we can do up to 64 millimeter bolts, 450,000 pounds of force, tension. The anchor bolts, obviously, we're seeing a lot of anchor bolts, especially in things like cranes and the windmills. The cranes is another area of high growth for us. We just did a Model K for the Freedom Tower that they're building in New York, the crane that's being set up to erect that tower. So we're hearing a lot about that type of thing, and it's an interesting in the crane industry. We're hearing a lot of reusing of bolts and other types of things that make us very, very nervous. So we're going aggressively after that market so we don't have more cranes falling down because that hurts us all. Obviously, I already talked about trends in wrenches. We're seeing a lot more of hydraulic torque wrenches, a lot more reaction arms. We've never addressed that in the past. We've now started to address that. We're selling a lot more of these torque reaction kits, attaching them to all sorts of units. Most of our units now are drilled automatically with the holes, so we just have to screw the thing on and we're good to go. Recent fun things we've been working on. We worked with an IndyCar team to help them. They had a couple wheels come off in the middle of races, and they didn't know what was going on. And they don't know anything about tension in that industry. We have worked with them pretty extensively and developed a special unit that they can use. You know, if anyone's seen a racing car, it's basically one lug nut right in the middle. We've specialized some of our equipment to test that type of thing. It was a fun project for us. We get to talk about it a lot, but there's some interesting areas where we have, people who have a bus wheel fall off, and they call us and say, we're not sure why this fell off. And people in the construction industry have known it for a long time, that too much tension is not necessarily a good thing. Too little tension is obviously a bad thing. They're just now learning that in that industry, and it's going to be a bumpy ride, but it's going to be an interesting one as we go along. I know Mitch from Eastern Pneumatic has addressed that quite a bit. I've talked a lot about windmills just because it's hot in our industry. The number of Ks that we're selling, which is the big unit, has tripled. And we're getting calls every day. We're working with all the major manufacturers of windmills to provide equipment that's suited specifically for their jobs. For example, Clipper now anytime Clipper sells a unit, they're going to sell a Skidmore with it with certain spacer bushings already set up for the job. And it's just the Clipper package, and we just put it together and send it for their 3 different towers. Dave can talk a little bit more about the missile thing we worked on. It was kind of fun. He worked quite a bit on it.
Yeah, I don't know actually that much of the detail because it's kind of secret, but they have problems with missile fins. If you're familiar with our F-16s, F-18s shooting down or shooting at other people, those missiles are several $1 million a piece. They're having problems. They launch a missile, one of the fins would fly off. Missile obviously wouldn't take out the target and would go to the ground, wasting $1 million and putting the pilot's life in jeopardy. So of course they go back to the supplier and say, why are these parts falling off? What are we going to do about it? Their answer is, we don't know. They finally figured out they're not properly tensioning the bolt. The bigger problem they have is the bolt was a one-use bolt. Once it was tensioned, they couldn't ever take it apart again, which I couldn't quite figure out how they could do that. But so they came to us and said, how can we test this? We took one of our small units that you guys probably have never seen, made up a test jig for them, put it in there, solved the problem. They figured it out. They understood their torque tension relationship, were able to implement a manufacturing process that would give them a consistent result, and hopefully it saves all of us taxpayers a lot of money. So those are the little things that we like to work on, because it's taking the knowledge that we have and applying it to something that we haven't done before. So it's pretty cool.
Go ahead, Gene.
And it's kind of interesting because aeronautics and structural steel, the only 2 industries use tension.
Right.
Everyone else uses torque. But there's a difference too between mechanical engineers, civil engineers, and aeronautics.
Mm-hmm.
But it's kind of neat to think that we're dealing. We have the same thoughts as someone building an airplane, or in this case,
Well, I made a presentation to a group of engineers at Northrop Grumman, and 90% of what they were talking about was so far above my head I didn't even understand it. But I did understand that that was an issue for them. They were trying to determine, they had some bolts just fall off of the space shuttle. And they're trying to figure out why. And at the speeds and the force that they're producing, that's a big problem. And they're trying to figure out what the cause of it is. And it's interesting, we did a special application for them because they have, everything is installed in a clean room there. And the oil in our unit that doesn't really come out, but microscopically probably does, they had to address that issue. And that's so far beyond what I do that, but it was interesting to me. That was an interesting afternoon. I've already talked about cranes. Obviously, with a couple falling down in Miami and a couple falling down in New York City, we're hearing a lot more from crane erectors and that industry. It's an unfortunate situation that you get the calls when those types of terrible things happen, but I think we have a solution, and we think we're addressing some of their problems. I only have one. Our number one frequently asked question is the temperature issue. I don't know if everyone's come across this, especially we hear about it with tension control bolts, and the honest answer is we really don't know the effect, whether it's the bolt that's the effect, whether it's the Skidmore that's the effect when the temperatures are especially low. We never hear about it at high temperature. It's always low temperature, people installing stuff at 0 degrees outside. Our position today is that if you own a unit with like metal parts, in other words, if you have our model MS, where it's a steel body and it's a steel piston, we believe that the unit shrinks uniformly when we've tested it, but not to the extreme that it needs to be tested. Below 20 degrees, there is an effect on the oil that is in the unit. It may take a little longer for the oil to get up into the gauge, but we believe that the unit will be reading correctly if you allow the oil to go through at below 20 degrees or below freezing temperatures. We do have a unit that's the Model HS that is an aluminum body. It's a steel piston. We know that below 20 degrees, the aluminum is going to contract more than the steel did. It's going to hinder the movement of the piston. I don't know if maybe this is a good time to go through what this unit actually does. It's a really simple device. We have a piston, and we have the body with O-rings between, and there's oil in there. as you squeeze this unit together, oil shoots up into the gauge. It's pretty simple. We're measuring PSI basically at that point. We've taken that device, put it on our presses, and calibrated the gauge to read in pounds of force, which we get from our press and is verified to NIST. So it's a pretty simple device. It's a hydraulic load cell, and we're just squirting oil into a gauge. There's nothing, you can't really fool the unit. There's nothing too fancy about it. It's pretty simple. Obviously, when I'm getting back to the HS, if the piston can't move back and forth in the unit because the aluminum has shrunk around it, the unit's not going to work. In those circumstances, we recommend that the customer take it into a heated trailer or something to do the testing. Now, obviously, they can bring the bolts in from the outside, keep them at the outside temperature. But we are working with the RCSC to do some more formal testing on the effects of temperature on, yeah. One of the things that Dave and I are very conscious of is we can do our own testing, but if we throw a bunch of numbers at you, if I'm sitting in your seat, I'm not going to buy it if I'm the one who sponsored the test. So we want to work with them, and you know, we can fund it, but we also want somebody else to do the testing. So go ahead.
I think you're gonna find that the lower temperature, especially with A325, up to minus 50 Fahrenheit, it's not gonna affect the tension of the bolt. It's not gonna be any change in the steel or anything. Below minus 50, then you wanna go to an A320 or cryogenic bolt. But the minus 50 degrees is not a problem. The thing we discussed a lot at Research Council, we were more concerned not so much with the shrinkage of the aluminum or the mounts or anything, but more the viscosity of the oil.
Sure.
Changing that at the lower temperatures, and that's where we were.
Yeah, I think the pour temperature of that oil is good down below 0 Fahrenheit, so it's still fluid. I can tell you exactly, but I don't remember off the top of my head. We have that.
You gotta remember too, you get into the northern part of the country, and we're
Yep.
outside working.
Sure.
20, 25 below every year in the wintertime. So those things you want to check. It's not, I can tell you now, it's not the bolt. You're not going to have a problem with the bolt. The only thing you'll have that will affect the installation of the bolt is the torque tension relationship you spoke about earlier. At lower and higher temperatures, the lubricant on the bolt or the oil coating will change. So you might change
True.
your friction coefficient from, say, a 0.16 to up to a 0.2 or down to a 0.11 or something. But it's not, it doesn't affect the bolt. You use nut rotation, you'll get the same tension at 70 degrees Fahrenheit as you would at minus 30.
Great.
Did it say that you should probably test a cold bolt in your warm skid more in that situation? Did it say that it's gonna react?
It really won't make any difference if you,
Unfortunately, they've got to turn this room, so if you, can you make this announcement for me?
Oh, sure.
on the colder bolts and stuff like that. It's like, for example, there was some bolts that they had a problem with a few years ago out in Nevada where the bolts were breaking. These happen to be TC bolts. Well, what they found out after I was out there and we looked at it was that it was the lubricant, and the lubricant was affected by the higher temperatures. After 10 o'clock in the morning, the temperature of the steel is up like 160 degrees Fahrenheit from the direct sun. The air temperature on a cloudy day, say 95 degrees, on a sunny day, the air temperature is 95 degrees, but the bolts didn't break on cloudy days. And it's because the steel wasn't affected by the direct sunlight.
Wow.
And that's, you know, these are
Interesting.
things that we've learned over the years by experience, you know, happens when you look at it and figure out what the cause was.
Great. Thank you for that input. Well, are there any other questions?
I got just one trivia question.
Okay.
Bolt guys. Can you over torque a bolt if it doesn't work?
No. If a bolt doesn't break during installation, unless it's subject to prying. No, you're not, an over-torque bolt is a broken bolt, or a strip bolt.
Strip.
Sure.
But if it doesn't fail, you can't overtime.
It's not over-tight.
Okay, Pam made asked me to make an announcement and cut it short because they got to turn this room. There is a hospitality suite in Land's End in the, I think that's Brighton building from 4 to 8. I'm assuming everyone's invited to that.
7:30 to midnight.
7:30 to midnight. Okay.
Tonight at Land's End.
7:30 to midnight. Hospitality suite, Land's End, Brighton building.
That's Brighton building.
Well, thank you for sitting around for us. If you have any questions, please feel free. Thanks.